Linear functions. Objective. By this lesson, we should learn how to graph and make equations of linear functions. So this is a linear function. A linear function is defined by f of x equal to ax plus b, where a and b are real numbers. What makes it a linear function is the fact that x here, a variable here, has the highest power of 1. That's the linear part. So what makes it a line is the highest power is 1. Now let's go a little more detail here. Our a in front of here is our rate of change. Let's make it a slope. Talk about that more later. Our b is the y-intercept it is, but we're going to talk about in the context of application problems. This is our initial value / starting point. Helps if I spell value correctly. Starting amount. So there we go. So when we have a linear function, and then we do an application problem, the a here is our rate of change. X is the thing that's changing its rate to, and b is our initial value. So for example, suppose that by noon 2 inches of rainfall have fallen. Rain continued to fall at a rate of 1/2 inch per hour in the afternoon. The total rainfall x hours past noon is given by this equation here. And you can see, suppose by noon I had 2 inches already. So that was my initial amount, 2 inches. That goes for my b. Our rate was 1/2 inch. So that goes for my a, right? Our normal, probably should write down, right? Our generic linear equations like this, right? So 1/2 is our rate. It goes there. My initial amount was 2. And x is the number of hours past noon. So we can figure out how much rainfall happened in so many hours past noon. So the question was, hey, at 3 p.m. the total rainfall is equal to what? Well, 3 p.m. is 3 hours past noon. We substitute 3 in for our x. We can simplify and get 3.5 inches. So that's how we use a linear function to solve an application problem. Anyway, so here's an example of a linear function with values inside it. So this is a linear function with two variables. Those two variables will be x and y. A solution to a linear function is an ordered pair that makes the equation true. So if I give you a couple examples here, if I say is 2, 5 a solution, is 315 a solution. The way you check these is you substitute 2 in for x, 5 in for y, and see if it's a true statement. So if I do the first one here, 5 is my y, 2 is my x. I get 5 equals 6 plus 6, which is 12. This is not a true statement, so no, it's not a solution. So 2, 5 is not a solution. Right? It didn't make the equation true. I tried 315, so 15 is my y. 3 times 3 plus 6, I get 9 plus 6 is 15 equals 15. So that does work. So 315 is a solution to the linear equation. And all that means is it's a point on the graph. That's all it means. So if we graph this linear equation, 315 will be a point on that graph. So solution, point on the graph, all kind of mean the same thing. So next, let's talk about how to graph a linear function by hand. So we're going to go over one way now, a little bit a different way later. But for now, the only way we know how to graph this is either make a table or find the x and y intercepts. So let's find the x and y intercepts first. So remember, the way you find the x-intercept is you set y equal to 0. So my equation here, I'm going to set 0 equals 3x plus 6. Solve. Divide by 3. And I get x equals -2. Now remember, it is an intercept, so it should be points. My point is -2 and 0. That's an ugly 2. That's my x-intercept. So if I was going to graph this, I'd go -2 and 0 right there. Now to find my y-intercept, very similar. We're just going to substitute x equals 0. So y equals 3 times 0 plus 6. So y equals 6. Again, it's a point. It's a point 0, 6. So 1, 2, 3, 4, 5, 6. Then we just connect those 2 points. And there we go. So that's how you graph a linear function by hand. So you can make a table, or we can use x and y intercepts. Eventually we'll learn how to graph using slope-intercept form, but that's coming up. Zeros of a function. So this is a definition. A zero of a function is just the x-intercepts. As you see here, if the zero is what makes the function equal 0, like that's what it is. When you plug something into a function, what value of that makes it 0? Well, that's the exact same thing as an x-intercept. Right, because in an x-intercept, you see here, we want y to be 0. So if I ask you to find the 0 function, I'm just asking you to find the x-intercept. I want you to make the equation equal 0. So the 0 of this function is right there, -2. Because f of -2 equals 0, right? I get the point -2, 0. So that's the 0 of the function. So let's do another example. And this one we're also going to try to do graph on the calculator. So if I want to graph this function, right, as I said, we could either make a table out of it or we'll find our x and y intercepts. X-intercept, we're going to set y equal to 0, also known as our 0 of the function. So in this case, you notice it's a function, it's f of x. Remember, f of x and y are the exact same thing. You could easily see this as this instead. So it serves the exact same purpose. So we're going to get 0 equals -2x plus 5. I'm going to solve this. I'm going to get x equals 5 over 2, or 2.5. So we have the point 2.5 and 0. Alright, now I want to find my y-intercept. So we're going to set x equal to 0. So I get y equals -2 times 0 plus 5. Which you guess gets us 5, so we have the point 0.5. Sorry about that. Anyway, when I graph this, to make a normal xy chart, we have the point 0.5, so 1, 2, 3, 4, 5. We have the point 2.5 and 0, so 1, 2, 3, 4, 5, 2.5. Connect these two. There's my graph. Now to show you the graphical solution, I'm going to bring in my graph here, my calculator solution. Turn it on. We're going to go to y equals, so that's our grapher. And then again, you notice that's y1, y2, y3, so just how many graphs do you want? F of x is the exact same thing as y, so all we got to do is type in our equation here. So -2, now here's the important thing. Negative is this guy. That's my negative one. This is my subtraction button. So you want to put -2. I need to type in x or any variable. There's only one button we use for variables here, and that's this variable button. So this will be our x. And then plus 5. And that's it. Now how do I graph it? You're going to hit graph. Now most of the time our window should be the default -10, 10. I think that's what I have here. Once you turn it on, that's what you get. You can see the y-intercept is 5 like I have, and it crosses like a little between 2 and 3. So there's a couple of things. If your window wasn't -10, 10, you can fix that. You go to zoom, standard, 6 here. So you just press 6 or go down, click it. That gets to the -10, 10 one. I do want to show you if I would have used a subtraction sign instead. So if I use a subtraction sign and hit graph, you get the error. Because again, you're using the wrong symbol. Subtraction 2x instead of -2x, -2x. Anyway, so that's how you graph on your calculator. Finding a formula for a function. So here we're gonna apply our linear function, f of x equals ax plus b, to an application problem. We're going to try to find up an equation using a linear function. So 100-gallon tank full of water is being drained at a rate of 5 gallons per minute. Write a formula for the linear function f that models the number of gallons of water in the tank after x minutes. So remember the way we talked about this? B is my initial amount. And then A is the rate. So as long as you have that down, all we have to do is substitute it and we have what we need. So for A, my function is going to be f of x equals, now what is my rate? Drain at a rate of 5 gallons per minute. Okay, so 5 gallons per minute, you could tell it's a rate because it has the per right there. Also, it said rate, but whatever. Now, keep in mind it's draining, so it's actually -5. We're losing water. Plus B, it's my initial amount. Right here, we have a 100-gallon tank full of water. So my initial amount is 100 gallons. So there's my formula. f of x equals negative 5x plus 10, where x is the number of gallons in the water, the number of gallons of water in the tank after x minutes. Question B, how much water is in the tank after 4 minutes? Well, again, x stands for water, x is for minutes, and I have 4 minutes, so substitute in x. So what's f of 4? Negative 2 times 4 plus 100, which gets us negative 20 plus 100, which is 80. That's 80 gallons of water. There we go. Use the x and y intercepts to graph and interpret each intercept. So this is good fun. So we want to find the x and y intercepts, so let's talk about it. So let's find the x intercept. All right, we're going to substitute 0 in for y. So in this case, that's our f of x. So we're going to get 0 equals negative 5x plus 100. So let's move 5x over. I get 100 divided by 5. I get x equals 20. So we have the point 20 and 0. Now before we move on to the y-intercept, let's interpret each intercept. So what does this mean? Well, let's keep in mind what each thing means. This is 20. This is minutes. This is gallons in the tank. Right? X is our minutes. F is the number of gallons of water in the tank. So what does this mean? Well, this is how long it takes to get the tank empty, essentially, right? 0 gallons in the tank. So when we find our y-intercept, that makes our y 0. So whatever the y we're talking about, that's 0. In this case, our y is gallons in the tank. So this is how long it took the tank to be empty. It took 20 minutes to empty the tank. Now let's find the y-intercept. Now the y-intercept, I probably don't even do any work. We just have to set x equals 0. We already know it. The y-intercept is just the 100. But let's do the work. Plug in 100. Plug in 0. Plus 100. I get 100. Again, that is a point. That is a point 0, 100. But the same idea. What do each of these things mean? This is minutes. And this is gallons of water in the tank. I probably have to do that because we talked about before. What is the y-intercept? The initial amount. This is the initial amount of water in the tank. That's what it always is, right? The y-intercept is always the initial amount. So in this case, we're talking about the initial amount of water in the tank. So 100 was the initial amount of water in the tank. So let's move on. The constant function. So this is when the function e just equals, and there's no x in it. There's no variable in anything. So this is a constant function. So you get, for example, you get f of x equals 3, or it's an ugly 3, or y equals 2. Those are constant functions. They're called constant functions because there's no variable. It's always going to be 2, right? There's no, like normally when we have a variable, that means that something changes. That this is changed number, plugging in 1, 2, 3. But when it's just a constant, you take that x away, well then it's always 2. It's constant. So how do you graph this? So x, y. The easiest way to graph this, remember, f of x is the same thing as saying y. So it's like saying y equals negative 3. So all you want to do is go to negative 3 on your y, and then follow the tally mark. So 1, 2, 3, that's negative 3. And then graph follows the tally mark. So it looks like that. And there you go. That's how you sketch a constant function. 4, example, finding a comprehensive graph of a line. So a comprehensive graph just means a graph where you could see the x and y intercepts. That's all it means. You can kind of see the main points of the graph. So find a comprehensive graph of this. So we're going to do this on a calculator. Because if we're doing by hand, we can just draw it. But the idea behind this is that if you try to draw this on a calculator, you won't get a nice comprehensive graph initially. So let's go back to y equals, and then type that in. So again, now that's a negative. So negative 0.75 x, 0.75 and 0.75, the same thing, plus 12.5. Now again, I still have mine on standard. I hit graph. And I could kind of see it. I gotta look at this 1.5. If this was any higher, I couldn't see it at all. So I want to be able to see both up here and over there, right? I can't see the y-intercept, but I can't see the x-intercept over there. So what we're gonna do is go to a window, and I need my, let's go back to my graph actually. I need to higher my y, and I need to higher my x. So my positive x, I'm gonna make that bigger, and then my positive y to make that bigger. My positive x to make that bigger. So my x min's fine. It's the right side I gotta see more of. So we could change that to anything. Let's just double it and go to 20. On my, remember we always want to keep scale at 1, and then my x min is fine. My x max I couldn't see how high should you go. Well, right here I know what the y min intercept is, 12.5. So if I hit 12.5, I could see it. But you always want to give yourself a buffer. So I'm gonna go all the way up to 20, so I can make sure I really see it. Then we hit graph, and then right there. So this is all the way up to 20. That's where the x-intercept, the y-intercept is right there. I push all the way to 20. Good thing I did, because it looks like it crosses around 16 or 17. But that's a comprehensive graph, so you want to be able to see everything when you do a graph. So sometimes you got to play with the windows. A couple other ways to play with the windows. Again, if I put zoom standard 6, I go back to the negative 1010. Always a good thing to do after you're done with your problem. And then sometimes you can also do zoom fit. You scroll down to zoom fit. Now, here's the thing about zoom fit. It won't change your x values. It only changes your y. So if I hit zoom fit, my x will stay the same, but my y's will move. They'll move my y's up. Now, this is not great for what we're doing because I still don't have my x-intercept. So it's good for other graphs we'll do in the future, but it actually isn't helpful for what we're doing right now. So I'm going to go back to zoom standard to reset. Okay, let's move on. Slope of a line and average rate of change. These two things are the same thing. Slope of a line is the average rate of change. And both of them are measuring basically how much of an angle does your graph have. So like this, compared to something like this, compared to something that looks like this. Right? How much of a tilt does it have? And the way we find it is we find the change in y over the change of x. We want to figure out how far it goes, what's the angle goes from here to there. This is called the change in x and the change of y. In general, triangle means change in math and science. So the change of y over the change of x, also known as rise over run. So the way we do that is we subtract our points. We do y2 minus y1 over x2 minus x1. You should have seen this in algebra 1 and algebra 2. Doing it over again here. So let's do an example. Use a slope formula to find the slope of this line. Now, since it's a linear line, I'm gonna pick any 2 points and then just use the equation. So we're gonna use the slope equation. Y2 m equals y2 minus y1 over x2 minus x1. I'm gonna pick 2 at random. It doesn't really matter to me. So here are these 2. Now again, these are my x's, so this is x1 and y1. Remember, they come in pairs. So this is like a point. It's like the point negative 5, 3. I'm going to do the same thing here. So it's be x2, y2. It doesn't matter which 2 you pick. It doesn't matter which one's x1, which one's x1 and x2. As long as you keep them pairwise, you should be fine. It's the exact same answer. So let me sub these in. So y2 is negative 5 minus 3, and then 9 minus negative 5. So I get negative 8 over, double negative makes positive, 14. I can reduce that, divide everything by 2. I get negative 4 over 7. And that is my slope. Again, you can pick any 2 and you get the exact same answer. Use the slope and a point to graph a line. Graph the line with the point of the line that passes through the point 2, 1, and a slope of negative 4/3. So this is how it's like a little lead into how to graph with slope-intercept form. So we want to graph a line given this point and that slope. So what we're going to do is start at this point here, 2, 1. There's our point. We'll do some more markings I'm going to need. So we're going to start at this point and we're going to use our slope. Now the way we think about slope is like this. It's the rate of change of slope. We want to think about it as rise per run. What that means is this. If you have a positive, you're going to move up. If you have a negative, you're actually going to fall, but we're always going to go right. So we're going to start at this point here, and then in our case, we have a negative 4/3, so we're going to fall 4 and then run 3. So we're going to fall 1, 2, 3, 4. Then we're going to run 3. 1, 2, 3. That, and that is our other point. So you start at this point, 2, 1, and then you follow the slope. And in my case, since it was negative, I'm going to fall 4. And run 3. That's my other point. And now that I have 2 points, I can just connect them. and that's my line. So that's how you graph a line only given a point in the slope. Okay, let's talk about slopes in general. So I'm going to have 3 little graphs here. So we're talking about the equation y equals mx plus b, slope-intercept form, where m is our slope, right? So it's a linear equation. Instead of a, we put an m there because that represents slope. B is our y-intercept. So what happens when the slope is positive? You should be rising. Like I said there, right? Positive, you go up, so it should be rising from left to right. When your slope is negative, well, when it rises, it should be like going up a hill. When your slope is negative, it should be falling, so it should be like going down a hill. When it equals 0, it's like a flat surface, so it should be easy to walk on. So it's a horizontal line. And then I say when the slope is vertical, I should consider it undefined because it's like a wall. How do you walk on a wall? That's why it's undefined, because you can't walk on a wall. So it's a straight line up and down. That's undefined. So there we go. So you have a positive slope, a negative slope, a zero slope, which is like, again, it's all like about walking, right? Walk up a hill, positive slope, walk down a hill, negative slope, walk in a straight line, walk on a flat surface, zero slope. And then if it's undefined, that means it's like a big wall, you can't walk on it. The way you graph vertical line is that x equals k. So for example, like x equals 3 makes it a vertical line. So all you do, x and y, go to 3 and follow the tally mark. That's how you want to graph the x or y equals 1. So you just go to that point and follow the tally mark. So we have 2 examples here. Give the x-intercept, the y-intercept, the domain and range, slope of the line if defined. Anyway, these are just lines. So they want to graph these. So we're going to graph f of x equals 2.5. Remember, f of x is going to be the same y. So it's like saying y equals 2.5. So here's x, here's y. Go to 2.5, which is like 2.5. And then follow the would-be tally mark. And there I go. By the way, if they want the domain and range, I can do that. The domain, farthest left, negative infinity. Farthest right, arrow, positive infinity. The range, there's only one number we hit, and that's 2.5. That's my range. My slope, I should have done the slope also. This is a straight line, so my slope is 0. It's like there's no resistance walking. That's an easy thing to walk. So there we go. X-intercept, there's no x-intercept. There is a y-intercept. It's just 2.5. So that's the y-intercept. Right, there's no x-intercept because you don't cross this at all. Next one, x equals negative 3. So let's draw that. Here's my x, here's my y. All we're going to do is go to negative 3 on our x, right here, and then follow the tally mark. Again, let's answer the same question. Let's do domain, let's do range, let's do slope, I guess x-intercept and y-intercept. My domain is my x value. There's actually only one x value you use. That's negative 3. So just like before. Well, just like the other one, but opposite. Negative 3. My range is the y values. And that one, we go from low, negative infinity, to high, positive infinity. My slope, remember what they say. It's a wall. It's a straight line up and down. You can't walk that. Undefined. My x-intercept, I do actually have x-intercept. I cross right there at negative 3. My y-intercept, I should have made this a point. Both of these. I was being lazy. My y-intercept, I don't have a y-intercept. So, no value. None. There you go. Next one, given the equation, give the equation line of the line illustrated. So I want to give the equation of this line. Both of these are, oh wait. No, both of these are kind of funky. Why did I pick these two? Anyway, this line here, it's hard to tell, but it's a horizontal line. So I should know, like, all I'm doing is following my y. So this is y equals something. And where does it cross? Here's 2, so 2, 1, 0. This is y equals 0. And then this one, it's the same thing, but again, it's a vertical line. So it's going to be x equals something. And where did you see it cross? Again, it's at 0. Let me do another one because I don't feel great. I don't like when they're exactly the same. 32. 1, 2, 3, x, y, 1, 2, 3. Let's draw a line that looks like this. So on that, what's the equation of it? Well, look at where you look at which tally mark you use, right? I use the y's. So I know, even though it's horizontal, it says a y equals graph, because that's where you're crossing the y-intercept. So it says y equals 2. Right, so this one was y equals 0, because you're crossing the 0 on the y. This one's an x equals. So there you go. Example 7, interpreting slope as an average rate of change. So in 2011, online sales on Thanksgiving Day were 479 million, and in 2016 these sales reached 1,287 million. Find the average rate of change in sales in millions. So remember, average rate of change is another way of just saying slope. So we're gonna find the slope. So to find the slope, we need the equation. M equals rate of change in y over change of x, also known as y2 minus y1 over x2 minus x1. So we need 2 points between x1 and y1. Well, they give us information. Have 2011 goes with 479 million. Say mil. And we have the point in 2016. Let's make that a point. Right, where it says years and this is millions. We have 1287. So there's my points. Where x is years and y is the amount of money we make, or they sale on Thanksgiving. So if I want to find the slope of this, the rate of change, which is the slope, I just had to use the equation. Y2 over minus y1 over x2 minus x1. So here's x1, here's y1, here's x2, y2. Remember, it doesn't matter, you could switch these two, you get the exact same answer. So using the equation, 1287 minus 479, 2016 minus 2011. When it's application, you're always allowed to use a calculator. When it's an application problem, I don't have one on me, so I'm just going to do this by hand. So 802 or 5. Again, this is in millions per year. So that's my rate of change. So let me actually divide it so I get an actual value. And I get 160.4 million per year. Remember, the million is on top. So the way you want to think about this, like a slope, right? It's this unit per, that's what the line is, this unit. So in this case, we have 802 million per 5 years. If you actually divide it, you get 106 million per year, right, for 1 year. Graph these as as a line segment and interpret the average rate of change. So I mean, sending it just did. I'm not going to do that because it'll be like a point there and something like that. So I'll just get that part of it. Slope-intercept form of a line. So this is slope-intercept form of a line, right? It's a linear line like you saw before. Just instead of the a, we put an m there, and the m represents the slope of a line, or the rate of change of a line, right? Rise over run. Slope-intercept form is used for graphing. Like that's what it's used most for. So right here is an easy graph, and my b is my y-intercept. This is usually your first point. Remember we did earlier where we use a point of slope to graph, right? Use a point first. So this is my first point. It's 0b. So that's your first point, and then use the slope to graph. Okay, let's use that to match these. We want to match these equations with these graphs. Let's look at the first one here, right? My y-intercept here is 3. So which of these has a y-intercept around 3? Well, this one and this one. Right, this has a y-intercept that's negative, has a y-intercept that's negative, so it's these two. So then, what's different between these two? The slope. Notice how this is rising, has a positive slope. This has a negative slope. So this right here, y equals 2x plus 3, has a positive slope, so that must be this guy. So that one's done. Next one, y equals negative 2x plus 3. Well, again, positive y-intercept, that's this one, and a negative slope, so it must be this one. Next one, y equals 2x minus 3, so it has a positive slope but a negative y-intercept. So positive slope and negative y-intercept, that's this one. Negative y-intercept but a positive slope. And then this one will be the last one, a negative slope and a negative y-intercept. So it should be crossing the bottom down here and it has a negative slope. So there you go. Okay, let's do an example. Graph each linear function given the x, y-intercept, domain, range, and slope of a line. Okay, we might do that some later, but let's first just graph it using the slope-intercept form. So if I was going to graph this using the slope-intercept form, my very first point will be my y-intercept right here, negative 6. So on your y, you can go to -6. 1, 2, 3, 4, 5, 6. Right? Because that's all this is. That's the point 0, -6. It's your very first point. So I have that down here. Next, we do the slope. In this case, the slope is 3. But we want a fraction, right? I want to make it rise or run. So anytime you just have a whole number, you put over 1. I'm going to rise. It's positive, so up 3. I'm going to run 1. Alright, so anytime we get a fraction, if you get a whole number, just make it a fraction. Put over 1. So we have a slope of 3 here. I'm going to go up 3 and over 1. And there is my graph using slope-intercept form. Now if I want to do the stuff they asked me to do, right? 1, if I want to find the x-intercept, I could just set y equal to 0 to find your x-intercept. Remember, f of x is 0. So 6 equals 3x, x equals 2. It's the 0.20. Right, all I did was add the 6 over, divide by 3, and I got x equals 2. So right here where I cross is at the 0.20. If they want the y-intercept, well, the y-intercept I already know. 0, -6, right? It's given in the equation. Done. The domain, I should do domain. The domain, farthest left, remember domain is your x. Farthest left is an arrow, -infinity. Farthest right, arrow, +infinity. My range, same idea. Lowest arrow, highest arrow. If you have a linear line, that's gonna be the main range every single time. -infinity, +infinity. And then the slope. I already did the slope. Slope is 3. So done. Last few problems here. Work each problem related to the linear function. So first, evaluate f of -2, f of 4. So just like a little review, all we're gonna do is substitute these values into this equation. So for a here, they want to know what f of -2 is. Remember, that's the same when you plug in -2 for my x, what's my y? Like all we're trying to do is find a point basically. So all we do is substitute it in. -1/2 times -2 plus 2. -1/2 times -2, double negative makes it positive. This becomes 1. 1 plus 2 is 3. So this is like the point -2 and 3. It is like the point -2 and 3, but I should just do what they asked me to, which is f of -2 equals 3. Like that's all they're asking for. Answer is 3. F of 4. Right, so same idea. We're going to substitute 4 for x. -1/2 times 4 is -2. -2 plus 2 is 0. So that's the answer. It is also the point 40, but again, that's not what they're asking. B, they want me to graph a function. Graph f. How can the graph of f use to determine the zeros of f? Okay, so let's graph it. Let's graph it using the y-intercept method. So my y-intercept is 2. It's my first point. Here's x and y. 1, 2. And my slope is -1/2. So remember, my slope here is -1/2, which means I'm going to go down 1 and over 2. So for my point right there, we're going to go down 1 and right 2. Remember, you always go right, up or down if it's positive or negative. Positive up, negative down, always go right. So the point right there. And connect it. So there's my graph. How can the graph of f be used to determine the zeros? So remember, it's all about definitions. What's a zero of f? That's the x-intercept, right? That's when the y equals 0. So you can use your graph to find it. Right here, it looks like if I grabbed it correctly, it should be at 3. Find the zero of f. So remember, without a graph, the way you find the zero of f is just the x-intercept. So you set y equals 0. So we're going to go 0 equals -1/2 x plus 2. So let's just solve that. Subtract 2 from both sides. -2 equals -1/2 x. The way you get rid of the fractions, you multiply by the reciprocal. So multiply both sides by -2 over 1. And it looks like my graph is a little off because I get 4. So that should be at 4. My graph is not perfect. So the zero of f was 4. Next one. Let me erase some of this. You can always pause anytime you want. Need that. Next one. Use the graph of the linear function to complete the following. Find the slope, y-intercept, and x-intercept. So they give us a graph. Find the following things. Find the slope. Now, easy way to find slope is always the same. Find 2 points and then either do the formula or do rise over run. Either way, though, you have to find 2 points to find the slope. So either way, I gotta find 2 points. So what I mean by that, you want to find 2 places that cross nicely. So if you look at our graph here, I'm gonna zoom in so I have that ability. I'm gonna use this point there, -3 and 0, and I'm gonna use this point there, 0 and -1. Now, if you want, you just use the slope formula. Right, y2 minus y1 over x2 minus x1. I'm zoomed in, so if the pen's still like thick. Anyway, it would be -1 minus 0 over 0 minus -3. Which give me -1 over 3, so -1/3. That should be my slope. But you can also do rise over run, right? So start from the left one, we go left to right, and I have to fall 1 to make a match. So go down 1, and I got to go right 1, 2, 3. So my slope would be rise over run, FL, -1/3. So either way I do that, you get a slope of -1/3. Right, so again, the way you find a slope, you just find 2 points, and either do the slope equation or do rise over run. The y-intercept, I can look at the graph. The y-intercept is -1. Right, where does it cross the y? Crosses at -1, and I should make it a point because I'm stopping lazy frugoso. X-intercept, same idea. Look at the graph. Where does it cross the x? Right there at -3, 0. So done. Write the equation defining f. So the easiest way to write an equation when you have a graph is to do this: y equals mx plus b. Right. All we need is our slope and our y-intercept. We have both of those. Our slope is -1/3, and our y-intercept is -1. So y equals -1/3, x minus 1. Easy enough. Finding these zeros. Remember, zeros are x-intercepts, so my zeros are -3, or is -3. I only have 1 0. This is the x-intercept. And there we go.